There is a star, hiding inside another star, not orbiting from a safe distance, not flying past, actually living inside the outer atmosphere of one of the biggest, most violent stars in our galaxy. For millions of years, it has been secretly circling in there, churning the gas around it, dimming the light we see from Earth, and driving astronomers absolutely crazy with a mystery they couldn't explain. And we had absolutely no idea it was there. Until 2025. Its name is Siwarha. It means her bracelet. And the star it orbits, the star it is slowly, inevitably being pulled into, is Betelgeuse, one of the most famous, most studied stars in human history. We thought we knew everything about Betelgeuse. We were wrong. For over 100 years, astronomers studying Betelgeuse kept bumping into something that made no sense. Betelgeuse pulsates. That's completely normal. Red supergiants breathe in and out on a regular cycle, brightening and dimming. Betelgeuse does this roughly every 400 days. Predictable, well understood, no mystery there. But hiding underneath that familiar rhythm was a second signal, a slower, quieter one. Every 5.9 years, like clockwork, Betelgeuse would subtly dim, then brighten again, over and over for a century straight. Astronomers called it the long secondary period, and it drove them mad because it didn't behave like normal pulsation. The star's temperature barely changed. Its surface didn't expand and contract the right way. Whatever was causing this dimming wasn't coming from inside the star. It was coming from outside. Theory after theory came and went over the decades. Dust clouds, magnetic storms, giant plasma bubbles on the surface. Each idea had something going for it. Each idea also had holes that couldn't be ignored. Nothing fit. The 5.9-year signal just kept repeating, decade after decade, with nobody able to explain it. Then in 2024, two separate teams of astronomers, working independently, with different data on different sides of the world, both arrived at the exact same answer. The long secondary period wasn't coming from inside Betelgeuse. Something was orbiting it. Something in a 5.9-year orbit. Close, massive enough to matter, and completely invisible to every telescope ever pointed at the sky. The ghost finally had a shape. Now they had to find it. Finding something orbiting Betelgeuse sounds straightforward. It isn't, not even close. Betelgeuse is one of the brightest stars in our entire night sky. Its light is so overwhelming that anything nearby, no matter how bright it might be on its own, is simply erased, drowned in the glare. The predicted companion would be 250 times fainter than Betelgeuse. Trying to spot it with a conventional telescope would be like trying to see a single candle placed next to a lighthouse on a foggy night from a mile away. Standard imaging wasn't going to work. The core problem is Earth's atmosphere. When light from a distant star travels through billions of miles of space and then hits our atmosphere, the turbulence bends and scrambles it. Long exposure photographs capture all of that distortion blurred together into one smeared mess. So astronomers used a completely different approach. Instead of one long exposure, they took thousands of images, each lasting just a few milliseconds. So fast that the atmosphere didn't have time to blur anything, each image frozen in a single instant. Then powerful software stacked all of those snapshots together, cutting through the noise, building a picture sharper than any single photograph could ever produce. This technique is called speckle imaging, and the instrument doing it, mounted on the 8.1-meter Gemini North telescope on top of Mauna Kea in Hawaii, was called Alipek. The team pointed it at Betelgeuse in 2020. They saw nothing unusual, but this was the plan. Orbital models predicted that in 2020, the companion was sitting directly behind Betelgeuse from our point of view, hidden by geometry alone. so they waited. In late 2024, the models said the companion would be at its greatest distance from Betelgeuse, its best possible window to be seen. The team looked again. There it was, a faint blue point of light, exactly where the models predicted. The right position, the right brightness, the right color. 100 years of searching, one perfectly timed photograph. They named it Siwarha, Arabic for her bracelet. A companion forever encircling Betelgeuse, the hand of the giant. So what exactly is Siwarha? Based on its brightness and color, Siwarha has a surface temperature of around 7,400 Kelvin and a mass of roughly 1.6 times our Sun. In plain terms, it's young, very young. While Betelgeuse is an ancient dying giant in its final stages, Siwarha hasn't even fully switched on yet. It's still in the process of becoming a proper star. Think of Betelgeuse as someone in the final chapter of their life, and Siwarha as a teenager standing next to them, still figuring out who they are. But here's where it gets genuinely strange. Betelgeuse is between 16 and 20 times the mass of our Sun. Siwarha is 1.6. That's a ratio of roughly 10 to 1. In the world of binary stars, pairs of stars that orbit each other, that kind of imbalance is almost unheard of. Stars that form from the same cloud of gas and dust typically end up with similar masses. Think twins, or at least siblings. Siwarha and Betelgeuse are not siblings. They're not even in the same league. Astronomers have a name for pairings this extreme mass ratio binaries. Until Siwarha, this was mostly a theoretical category. We knew systems like this could exist in principle. We just never directly seen one at this scale. Siwarha just made it real. And then there's this. Betelgeuse rotates faster than it should for a star its age and size. The leading explanation is that Siwarha's gravity, pulling on Betelgeuse across millions of years of close orbiting, has been gradually spinning the giant up, like a hand slowly winding a top. The bracelet has been winding the hand all along. Now here is the detail about Siwarha that makes it unlike almost anything else we've ever found. It doesn't orbit Betelgeuse from a safe, comfortable distance. Its orbital path sits at roughly 4 astronomical units from the center of Betelgeuse, closer than Jupiter is to our Sun. Our Sun is an average-sized star. Betelgeuse is 700 times larger. Its outer atmosphere, the thin, extended envelope of gas that surrounds the visible surface, reaches out at least 6 stellar radii beyond the star itself. Do the math, and you get something extraordinary. Siwarha's entire orbital path is inside Betelgeuse's atmosphere. It doesn't orbit around Betelgeuse. It orbits through it. Every single pass, Siwarha plows through gas and plasma. And just like a boat cutting through water, it leaves a wake behind it, a dense trail of compressed gas and dust that fans out and expands as it moves. Hubble Space Telescope tracked this wake directly. 8 years of observations revealing a moving trail of disturbed gas, spreading, expanding, covering a wider and wider portion of Betelgeuse's visible face as the orbit continues. That wake expands at roughly 6 kilometers per second. As it thickens, more gas, more dust. It blocks more of Betelgeuse's light from reaching Earth. And that is the 5.9-year mystery solved. Every time Siwarha completes one full orbit, its dusty wake reaches maximum coverage across Betelgeuse's disk. Betelgeuse dims. Then Siwarha moves on, the wake clears, and Betelgeuse brightens again. Reset, repeat, every 5.9 years for a century. One hidden star, one expanding wake. 100 years of confusion explained. You probably remember 2019. Betelgeuse suddenly dropped to 40% of its normal brightness over just a few months, the most dimmed it had been in recorded history. News spread fast. Astronomers openly discussed whether a supernova was imminent. whether we were about to watch one of the most dramatic events in naked-eye astronomy play out in real time. It didn't explode. Betelgeuse slowly recovered, and the accepted explanation emerged. A massive burst of plasma from the star's surface had cooled into a cloud of dust, temporarily blocking a huge portion of its light. That explanation still stands, but Siwarha rewrites part of the story. In 2019, Siwarha was in a part of its orbit where its dusty atmospheric wake was already beginning to spread across Betelgeuse's disk. The plasma ejection was the main event, but Siwarha's expanding wake contributed, deepening the dimming, extending the recovery, layering on top of the dust cloud in a way nobody could see at the time, because nobody knew Siwarha existed. The great dimming wasn't one event, it was two, happening simultaneously. And for 6 years, we only had half the explanation. Siwarha's story has an ending already written, and it isn't a gentle one. Because its orbit runs entirely through Betelgeuse's outer atmosphere, every single pass costs it energy. The gas it plows through creates drag, not enough to notice in a single orbit, but across thousands of years, it adds up relentlessly. The math gives Siwarha less than 10,000 years. After that, it will have lost too much orbital energy to maintain a stable path. It will begin to spiral inward, closer and closer, until it is pulled all the way in and swallowed by the star it has orbited since the beginning. There's a second possibility, and it's even more sudden. Betelgeuse itself is dying. Its supernova is estimated somewhere in the next 100,000 years. Astronomers can't narrow it down further than that, so the question becomes, which comes first? Does Siwarha spiral inward and merge with Betelgeuse, potentially changing the final moments of the giant's life and the nature of the explosion itself? Or does Betelgeuse go supernova first, sending a wall of energy outward at a fraction of the speed of light, obliterating Siwarha in an instant before it ever gets the chance to spiral in? Two possible endings. Neither one lets Siwarha survive. A star born alongside Betelgeuse, shaped by it, trapped by it, destined to die by it, either slowly consumed over millennia or vaporized in a single second. That is Siwarha's fate, and somehow, knowing it makes the bracelet feel more real. Siwarha matters beyond Betelgeuse, way beyond. Across our galaxy, there are hundreds of red, giant, and supergiant stars showing that same mysterious, long-period dimming signal, the exact same pattern that puzzled astronomers about Betelgeuse for a century. For decades, the assumption was that these signals were internal, some unknown pulsation deep inside the star. Siwarha suggests a completely different answer. Some of those stars almost certainly have hidden companions too, orbiting inside their atmospheres, invisible, shaping their behavior from within. We just haven't looked at the right moment, with the right instruments. We may have been misreading an entire class of stars for 100 years. The next chapter comes on November 26th, 2027. Right now, Siwarha is hidden behind Betelgeuse's disk, but in 2027 it will emerge again into its best viewing position, and this time astronomers will be waiting, with sharper tools and every question the 2025 discovery left unanswered. Tonight, if you go outside and find Orion, look at the red star burning at his shoulder. What looks like one point of light is actually two. A dying giant slowly pulling its young companion toward its doom. One ancient and enormous, one young and trapped, both moving toward the same ending, just on different timelines. Siwarha was always there. We just finally learned to see it.